Hi there, welcome to a introduction about WhenAny and WhenAnyValue, which are a mechanism inside ReactiveUI to get notified when properties change in value. They'll use observables, which, if you think about it, are a form of link that you can use to modify events and also notifications about things happening. And so we're going to demonstrate that to you guys today, how you can use those two operators within Reactive UI to make a very uh, complex operations, but it's actually fairly simple. But Rodney's going to present the material today. I'll be kind of observing and making comments as we're going through. And I'm going to hand it over to Rodney. Go for it.
Thank you, Glenn. All right, so we're going to go ahead and just jump right into the mix. So we've got our main view model right here, which inherits from our reactive object, which is the base extension point for notifying property changes in reactive UI. So public view model.
So can you tell me why a constructor, by the way? Just out of curiosity.
So in reactive programming, the majority of the time we're declaring what our code is going to do and what our code is going to look like. So we actually declare what should happen when state changes in our constructor. And then the object is constructed and it just reacts to state changes.
Yeah. Because you want to specify once, right? So it kind of makes sense, I guess.
Yeah, there's actually a lot of reasons, but the main thing is like the constructor is basically where the object is composed. So we want to catch the object and set up how it should react to state changes when the object is composed.
So let's look through what you've written so far. So it seems to be something missing called time.
Yep.
So I'm guessing what will that be, a property?
Yeah. So time is actually going to be a property that we're going to put just a simple date time offset. Call it time. Yep. We're going to give it reactive properties. So in reactive UI, this is the standard way for notifying property change. We have some FODs that allow you to provide a reactive attribute, which will give you the value out that will actually transform this code for you in the IL. But I'm electing to do it this way so that way we can show off what it would look like if you were a first-time consumer just trying it out and not understanding exactly what the FODs would bring to your...
Yeah, so let's have a look at that raise and set of change so people can get an idea
Sure.
of what it's doing, I guess.
Sure.
So we have our reactive object, which is our extension object. We have our backing field, and what we're doing is we're taking advantage of C#'s reference passing. So reference allows us to modify the value of the original value. We also passing on the new value that we want to set. So, and we're also passing on the property name. We're using a fancy feature in C#6, I think they introduced it, where it transforms that property name into the value of the method that's calling it. So it gives it the same, like if in our example was time, and back in our previous example, that will be filled with time automatically by the compiler for us, which is pretty cool. We do some checks to make sure we have a property name, and then we use this thing called a quality comparer. So pretty much every object, you can compare its value compared to another value. So we're just using a default quality comparer to determine if the values match or not. If they match, there's not much we should be doing. So then we just return, the new value and leave it at that. But if they don't match, then we probably should be notifying people about it. So we support iNotify property changing. So in this case, we're going to notify the outside world that the property is changing. We haven't changed it yet to give you a chance to do some code there. Then we actually modify the value, and then we notify the outside world that the value has changed. And then we just return the new value just as a helper. Most people will probably ignore that, but it's there if you need it.
Thank you
And
very
this
much.
all works off iNotify property change and iNotify property changing.
Yeah, directly out of the .NET framework, yes?
Yeah, so it's the standard feature that you find.
So back to our example, we've got a WhenAnyValue on our time object that explicitly implements iNotify change, right? So when the property changes, it's going to raise the iNotify change event if it's actually got a new value. And here we're going to turn that into an observable of date time offset time values. So every time the state of time is different, we will get the new value of what that time difference is. And then we're just going to subscribe to it and just write it out to console.
Yeah.
So that'll get us a good part of the way, but now we actually need to provide it a value. So in lieu of doing a complex UI, to make this simpler, what we'll do is we'll just go ahead and create a timer, right? So we'll go ahead and do observable.interval.
So for those who don't know, an interval would just keep firing at the specified interval until you dispose the value returned from our subscribe. So this is a really easy way to do some fairly complex code pretty easily. So in this case, we're getting the current time. That's where the select comes in. And then we're just doing subscribe, and we're just setting that property with the subscribe, which will then trigger our iNotify property changes. And this will happen once a second.
Right. So now, again, in our constructor, we've just constructed another observable that will get created during object composition, and then it will just go do the work that it's supposed to do. So we've got the system.write console. Let's go over here and check and make sure that our program is set correctly. We are set correctly, so let's go ahead and fire off the code.
And there you go. Once a second, we're outputting the current time.
The current time.
So let's go back to that program you just made. So here's a question I have for you. That program, what thread will it run under with the observable there?
So this, I think, is actually going to run on the immediate scheduler, if I'm not mistaken. So I actually ran into an issue a couple of weeks ago with console scheduling is different than Xamarin scheduling. There really is no UI thread to run on in a console application. So I'm pretty sure it's going to run on the immediate scheduler.
Yep. If we were running in Xamarin Forms, though, we could make this run on the main UI thread, right? How would we do that?
So how we would do that is actually pretty easy, right? So ReactiveUI provides a static extension point called RxApp, and you can get access to the main thread scheduler. Now this will actually be the main thread for whichever platform that you're running on. Yeah. So
obviously on console, there is no concept of a main thread, so I'll just go on whatever it can.
Yes, exactly. And placement of this actually matters, because what will happen is the next function in the observable pipeline will actually execute on the let me rephrase, it will marshal back to the thread that is set in this observe on.
So basically everything after the observe on, if we do other operations, that'll happen on that main thread now.
Yeah, so like let's say we did like a distinct until changed, right? This will now fire on the main thread.
Yeah.
Yeah.
That's pretty cool. So yeah, so you can see how we can chain up things very quickly for very complex logic, I guess.
Oh yeah. And it's robust, right? Because we can move around different threads. We can tell, like the interval, for example, we can actually tell the interval to run on the task pool and then explicitly bring it back. So in a Xamarin application or a WPF application, if you wanted a timer on your screen, you could actually have the interval running on a different thread, but just marshaling itself back to the UI thread when it needs to output itself.
Okay, that's pretty cool. And how about if we want to do on the WhenAnyValue, let's say we have the scenario where we've got a text box we're binding to, and some of these UI platforms don't really like properties that we're binding being run on separate threads. How can we modify our WhenAnyValue there?
So I'm pretty sure we could basically just put this here and observe on the main thread, and then when the subscription happens, it'll happen on the main thread.
Yeah, that makes sense.
Yeah.
That's pretty cool. So what about like we'll have one that goes every 2 seconds or something? Maybe that's a good one to go based on or something.
Okay.
So in a interval that fires every 2 seconds or something like that.
That makes sense. That makes sense. Okay, so then let's go ahead and do that, right? So what we'll do is we'll go ahead and put time 2, yeah, just because that's a good pun. We'll go time 2.
Almost. I see you're making great use of all the refactor tools in Rider there.
Oh yeah, Writer's refactor tools are pretty good. You know, we talk about this quite often, Glenn. There's a couple of kinks that are in it, but you know, because I'm developing on Mac full time, it's a good go. It's definitely a good go. So let's go ahead, like you said, and let's take. Actually, you know what? Let's do this. Let's take this whole thing and let's copy it out. We'll go ahead and make this a 2-second interval, like you said. They'll take the date time offset. We'll set this to time 2. So to show off the features of WhenAnyValue, we'll go ahead and add time 2 to the mix, right? So we can add multiple properties or chain properties for a WhenAnyValue. And WhenAnyValue under the hood will give us property change notifications when those properties emit values.
Okay.
So we'll go ahead and take time and time 2.
So in this case, let's just make a string of the 2 values concatenate or something.
Sounds good. So we'll go ahead and do time. Let's do that. Yeah. So let's go ahead and do string interpolation because string interpolation is great. And we'll do. All right. So then we'll go ahead. Now this becomes. We can replace that with a method group. We're gonna take this off because I don't. Well, you know, we'll leave it on and see what happens.
Should work.
It should be
I
fine.
think also we just provide a just give it some meaning.
Okay, just make sure all the code is wired up so that when I slam F5, everything will work. Here we go.
There we go.
Yeah. So now we've merged these 2 values together. Yeah, there we go. Yep, we see it happening there.
So we can see one's a little, although we're getting duplicated outputs, because that makes sense because one's firing more often than the other, but we'll get notified we'll get both outputted. So even though the 1-second one's getting outputted more often than the 2-second one, because it's a combined WhenAnyValue there, both will be mutated into that string. So, which kind of makes sense. So, yeah.
Yeah, so we're actually getting a property change notification emitting when time ticks and when time 2 ticks, right?
Yeah.
Perfect. So that means we're outputting every time either one of these values ticks a value.
Yep.
Nice. Okay. Cool. So I got one last trick in my bag, and that comes down to, you know, this time 2 is really nice and all, but we could probably make that a little bit better, yeah. Just sticking it in a subscribe, maybe not the best way to do it, or better yet, even I guess the console.write line wouldn't be one that we want to do, but we guess we can do that, yeah.
Yeah, it's handy in a console app, but in a real world one, you probably want it in a property or something.
Okay, so let's figure this out real quick. So let's pause that and let's think. Do we want to put the 2 property on this, or do we want to put the 2 property up here?
Probably on the WhenAnyValue above, and then move the right line into the program. So it's more like a real program.
Got it. Okay. All right. So let's bring it back. All right. So what we'll do is we'll go ahead and change this so that the calculation of the WhenAnyValue gets dumped into a property, and then that property can get emitted every time that the property change notification happens for it. So that way we can get our view concept, which is our console write line, out of our view model, and make this a little bit more robust. Yeah. So out here, what we'll do is let's figure that out. What are we going to call this property? Yeah. So this is going to be, let's call it time sync, because that's what things are, right? So we'll do a public string time sync. And I'm just going to leave that there for now, just to come back to that in a minute. Okay. So here we'll go ahead and remove this, and we'll do a .toProperty. And what ToProperty does is it will effectively cache the last value of the observable pipeline and provide that as a single instance value for you to bind to your UI. Because no UI kit really works correctly with observables. So ToProperty will provide an actual property output for the last value that came through the observable pipeline.
So the way I like to think of it, which some users may have experience with this, some might not, it's kind of like the lazy that you have in normal C#. It allows you to kind of like have an object that handles the sort of like having the value set from every time the observable change, and also handles automatically notifying, doing your notify property change events for you. So see how we're doing this .value? That's very much like the lazy pattern that you see in a lot of C# applications.
That makes a lot of sense.
And what it does is just stores only the latest value from the observable, and then triggers an notify property change and notifies the outside world that a time sync has changed. Is effectively what it's doing.
Let's go back over here to the program.cs, and how are we going to make this so that we can get all the values that come out of here and just write them out to the console, Glenn?
I think we just do another WhenAnyValue, right? But if we're doing it in a UI application, we've also got the binary mechanisms that we'll do another video about at another time. But given that we're focusing on WhenAnyValue, we'll just do that again. I probably would just do it on the main view model.
Oh, just on the main view model itself. Okay, main view model dot WhenAnyValue. There we go, because then we get access to the actual property. That makes a lot more sense, Glenn. Yeah, time sync. And then we'll just do subscribe time console dot write line.
So the nice thing about this approach that I'm seeing is we can use this on an actual UI now rather than just a console app, because we've separated how we're going to use this from a view point of view out from the actual view model, and now we've made it in this case we just got a console, but we've made it a view problem, right?
Yeah, and I think that's kind of the power of MVVM and understanding MVVM is being able to put the correct concerns in the correct places, and showing that ReactiveUI can be used both in a view concern, even though it's a console application, to provide that same MVVM experience.
Yeah.
All right, so let's go ahead and fire this thing up, Glenn, and see how wonderful we did the thing.
And there we go.
And there it is. So effectively, what we've done is when any value of the first time or the second time happens, we've selected out both of them. We've given you a string. We're observing on the main thread, and we're providing a property that gives you access to that value. Then in our view, we are stating anytime that value ticks, go ahead and write it out to the console. All right.
That looks pretty cool. I mean, we've separated things out. We're showing off a little bit. We go back to that observable property helper. I wouldn't mind just mentioning a couple of nice things about it. Number one, when you subscribe to that ToProperty there, it automatically knows what thread that you're currently on when you're calling this constructor. So it will by default go onto that thread that and often you're just creating them on your UI thread, right? A lot of these view models. You can override that. So in that ToProperty, there's a scheduler property.
Yep.
So you can make that like go onto another thread.
Like the task pool
so
schedule.
maybe the task pool one or whatever.
Yeah, the task pool.
So that's pretty cool. So it takes care of a lot of our threading issues for us. You know how we were talking about with WhenAnyValue before, you know, for a UI application like Xamarin Forms or WPF, they don't like properties that being binded to the UI being on a different thread to the main UI thread. So this allows us to have a bit of control over that, which is quite nice.
That is nice.
Yeah.
Okay.